Hi everybody, this is Mr. Raed Al-Nusayrat. Today, inshallah, we will talk about lesson 3.7, derivatives of exponential and logarithmic functions from grade 12 advanced term 1. We have some learning objectives today. The first one is find the derivatives of exponential functions. The second one, find the derivatives of natural logarithmic function. And the last one is solve real-life problems using derivatives of exponential and logarithmic functions. Also, we have some keywords today: exponential function, natural logarithm function, and logarithmic differentiation. We will start now in theorem 7.1. For any constant a greater than 0, d by dx for a to the power x equal a to the power x ln a. So in this theorem, we will talk about the derivative of the function a to the power x. In this example, find the derivative of f of x equal 3 to the power x. As we see in the theorem, we can see here f prime of x equal. Now, the first step, a to the power x, it's stay the same, so it's 3 to the power x times ln the base, which is constant, which is ln 3. This is the derivative using theorem 7.1. Theorem 7.2, we talk about the derivative of e to the power x, which is e to the power x. Why? Because if I use theorem 7.1 on the function e to the power x, will give me, so if y equal e to the power x, y prime equal e to the power x times ln e. Now, what about ln e? Ln e all the time equal 1. So what's the final result? It's e to the power x times 1, which is e to the power x. Find the derivative of f of x equal 2x minus e to the power x. F prime of x. Here we have subtraction between two functions. So the derivative for 2x, it's 2 minus the derivative of e to the power x from theorem 7.1, which is e to the power x. F of x equal a to the power g of x, and a is greater than 0, g of x is differentiable at x, then f prime of x equal a to the power g of x times g prime of x times ln a. Now we will use this definition to find derivative for some functions. And the derivative of the function, we have three functions here, so we'll start from the first one. F of x equal 3 times 4 to the power 2x squared. F prime of x equal. Now 3, it's a constant times function, so it's a state times derivative 4 to the power 2x squared, as the definition up, will give me 4 to the power 2x squared stay the same times derivative of the power of the exponent, derivative of 2x squared, which is 4x, times ln the constant in the base, which is 4, so it's ln 4, equal 3 times 4, it's 12, so here I have 12x ln 4 times 4 to the power 2x squared. The second one, g of x equal 3x times 2 to the power 1 over x, Here I have product between two functions. So g prime of x equal the derivative of the first one, which is a 3, times the second function, which is 2 to the power 1 over x, plus the first function 3x times the derivative of the function 2 to the power 1 over x, and I will use this definition. So first of all, it's stay the same. It's 2 to the power 1 over x times derivative of the exponent of the power, which is 1 over x. The derivative is negative 1 over x squared, times ln the base, which is ln 2. So here the first term is 3, 2 to the power 1 over x. Here I have plus times minus will give me minus x with x squared, 3 over x, because x will cancel with one of x's in the denominator. Ln 2 will come in here, so ln 2 after that times 2 to the power 1 over x. So this is the simplest form. If I need more in simplifying, I can take 2 to the power 1 over x as a common factor. So 2 to the power 1 over x. After that, open bracket. Here I have 3 minus. I can take 3 also as a common factor. So I will take it. So 3, it's a common factor also. 2 to the power 1 over x, it's a common factor. Now here I have 1 minus ln 2 over x. Because 3 and 2 to the power 1 over x, I take it outside as a common factor. The last one is h of x equal 5 to the power 3 minus x squared. It's go directly to the same definition. So h prime of x equal, first of all, 5 to the power 3 minus x squared. It's stay the same. After that, derivative of the power, which is negative 2x times ln 5. Now we will talk about derivative of the natural logarithm. In theorem 7.3, for x greater than 0, d by dx for the function ln x equal 1 over x. Now, why here he take x greater than 0? Because ln x, the domain of this function is x greater than 0 only. We will use this theorem to find derivative of each function here. So the first one, f of x equal 3x plus ln x, f prime of x equal, here I have addition between two functions. So the first one, the derivative is 3 plus derivative of ln x from the theorem will give me 1 over x. In the second function, I have g of t equal t squared ln t. Here I have a product between two functions. So I will use the product rule for derivatives. So g prime of t equal derivative of the first term, t squared, it's 2t times ln t plus t squared, the first function, times the derivative of ln t, which is 1 over t. So 2t ln t plus t squared over t will give me t. So the final result is 2t ln t plus t. If you want to take t as a common factor, no problem, t. So here I have 2 ln t plus 1. F of x equal ln g of x greater than 0 and gx is differentiable at x, then f prime of x equal g prime of x over g of x. Here I have generalizing for the last theorem. So I talk here about any function inside the logarithm, but this function must be greater than 0 and differentiable at x. The derivative is g prime of x over g of x. In this example, find the derivative of each function. F of x equal ln x squared plus 3. So f prime of x equal derivative of x squared plus 3, which is 2x over x squared plus 3. Because the definition of say that we must have the derivative of the inside function g of x, which is x squared plus 3 here, and the derivative is 2x, over the inside function, which is g of x here, it's x squared plus 3. G of x equal ln 1 minus 2x to the power 3. Here I can use directly this definition, but we will remember here an important thing, which is some conditions, some specialist things for logarithm. We remember that if we have ln x to the power n, this function equal n ln x. So I can take the power down. So ln x to the power n equal n ln x. Before I start finding the derivative for g of x here, I will use this to simplify this function before derivative. So g of x equal 3 ln 1 minus 2x. After that, I will start by the derivative of g of x. So 3, it's a constant, stay here. After that, the derivative of ln 1 minus 2x, using the definition up, it's minus 2, the derivative of the inside function, over 1 minus 2x. 3 times minus 2, it's minus 6, over 1 minus 2x. Logarithmic differentiation. If you have a function like f of x equal x to the power x, look here, the base is x, and the power also, it's x. So this function is not a power function. Why? Because the exponent is not a constant. The exponent here, the power here, it's x, not a constant. So because it's not a constant, I can't say that this is a power function. Also, this is not an exponential function, because the base, which is x also, it's not a constant. So this function is not the power function and is not an exponential function. So I cannot use the previous rules to find the derivative of x to the power x. What can we do here? Let me check with you. Find the derivative of f of x equal x to the power x where x is greater than 0. First of all, I will take the logarithm, natural logarithm, for both sides. Ln f of x equal ln x to the power x. Ln f of x equal, from logarithmic rules, x will go down, x ln x, because the power will fall down. Now I have both sides, left side and right side. I will start by finding the derivative of each side. So d by dx for the left side, which is ln f of x, equal d by dx for the right side, which is x ln x. What about the derivative for the left side? The derivative for ln f of x, it's f prime of x over f of x. What about the derivative for the right side, x ln x? X ln x, it's a product function, so the derivative of x, it's 1 times ln x plus x times derivative of ln x, which is 1 over x. So here, f prime of x over f of x equal ln x plus 1, because x will cancelling with x. This f of x, I will take it to the right side by cross product. So f prime of x equal f of x times ln x plus 1. F of x now, from the beginning, it's x to the power x. So x to the power x times 1 plus ln x. It's the result of derivative for the function x to the power x. Now you have 5 minutes to find the derivative of the function f of x equals sin x to the power x for sin x greater than 0. Please pause your recording while you solve the question. After that, we'll back again. Okay, we'll come back again. Let me check with you how can we find the derivative for the function sin x to the power x. As we worked in the last question, ln f of x equal ln sin x to the power x. Ln f of x equal x times ln sin x. Now I will find the derivative for both sides. So d by dx for the function ln f of x equal d by dx for the function x ln sin x. The derivative for the left side is f prime of x over f of x equal, here I have a product between two functions, so the derivative of it's 1 times ln sin, so it's ln sin, plus x times derivative of ln sin x, derivative of sin, it's cosine over sin. Now f prime of x over f of x equal ln sin x plus cosine over sine, it's a cot, so it's x cot x. After that, the last step, I will take f of x to another side by cross product, and don't forget that f of x, it's sin x to the power x. So sin x to the power x, which is f of x, times ln sin x plus x cot x. It's the last result for the derivative of the function f of x equals sin x to the power x. Now we have small recap here. Please don't forget your rules today. For any constant a greater than 0, d by dx for a to the power x, it's a to the power x ln a. D by dx for e to the power x, it's the same to the power x. f of x equal a to the power g of x, where a greater than 0 and g of x is differentiable at x, then f of prime of x equal a to the power g of x times g prime of x times ln a. For x greater than 0, d by dx for the function ln x, it's 1 over x. And the last thing is f of x equal ln g of x, where g of x is greater than 0 and g of x is differentiable. F of prime of x will be g prime of x over gx. Thank you very much